Basically, entropy. What is the entropy? Entropy is the measurement of disorderness or randomness of molecule is known as entropy. For example, ice gives water vapors. Ice gives water vapors. Ice is the solid, water is the liquid, it is gas. Actually, entropy, maximum entropy is present in gas, then in liquid, then in solid. Solid has least entropy. So, when we move in forward direction, then entropy of the system increases. Because solid is converted into water and water is converted into water vapor. And when we move in backward direction, then entropy decreases. Right? So we can decide in which process entropy increases or decreases. See here, we write down the some processes decide entropy increases or decreases. For example, boiling of egg. Combustion of benzene. These two are the important process. Combustion of benzene at 27 degrees centigrade. Combustion of benzene at dissolution of sugar in water. How we decide entropy increases or decreases in the following process. See here, boiling of egg. Basically, these two processes are the important process which is seems in this process that is not the answer. For example, in boiling of egg, you see liquid is converted into solid, then entropy must be decreases. But the answer is entropy increases. Because we provide the heat to the egg, so heat always increases the entropy. How it increases the entropy? Basically here denaturation of protein takes place. Protein is present in four structures: primary, secondary, tertiary and quaternary. Quaternary is the complex structure, and when you provide the heat to the egg, then quaternary structure breaks down and it is converted into primary structure. Fragments are present, so entropy increases because denaturation of protein takes place. So in boiling of egg, entropy increases due to the denaturation of protein takes place. Note down this thing. And in the stretching of rubber band, when you stretch a rubber band, then entropy must be increases because space is present, but the answer is entropy decreases. Why it decreases? Actually, when you stretch the rubber band, then all the molecules are present in a linear structure. All the molecules are present in a linear form, so its orderness increases. So entropy decreases. So this is also the important case, entropy decreases. And in dissolution of sugar in water means solid is converted into liquid, so entropy increases. This is the easier one. Now What is about combustion of benzene at 27 degrees centigrade and at 127 degrees centigrade? What is the role of this temperature? Actually, here physical state of each reactant and each product are most important at this temperature. In any reaction, if number of gaseous product increases, then entropy increases. No matter how many liquid and solid products are product or reactants are present, no matter. Only you see the number of gaseous product. Left the liquid or solid product or reactant. See only the gaseous reactant and product. If number of gaseous molecules increases, then entropy increases, and if it decreases, then entropy decreases. See here, actually boiling point of benzene is 78 degrees centigrade, for your knowledge, and the boiling point of water is 100. You already know that. So at 27 degrees centigrade, benzene and water both are the liquid. Write down the equation of benzene. It is liquid, 15/2 O2 gas, 6 CO2 gas plus 3 H2O liquid. See here, gaseous product is 7.5. Here gaseous product is 6. Not considered water, not considered benzene, 7.5 to 6. So what happens? Entropy decreases. So in combustion of benzene at 27 degrees centigrade, entropy decreases. Entropy decreases. And combustion of benzene at 127 degrees centigrade. At 127 degrees centigrade, benzene is present in gaseous state, water is also present in gaseous state. So here at 127 degrees centigrade, it is gas, H2O gas. Here total number of moles is 8.5, it is 9. So it increases because all are present in gaseous state. So physical state of each reactant and each product are most important. So here entropy increases. So these are the theoretical questions. Now for numericals, two formulas are present. Then you can solve any question. Actually, absolute entropy cannot be calculated. Absolute entropy or enthalpy cannot be calculated. Only we can calculate delta S or delta H. Absolute form is not calculated. See here, how we solve the numericals. These are the theoretical question. Actually, delta S is equal to delta H upon T. Use this formula. Basically, on increasing the temperature, change in entropy increases or decreases. By seeing the formula, it is the part of denominator. When it increases, then it should be decreases. But no, here delta S increases because delta H is not the constant. When temperature increases, then delta H increases more. Delta H is the function of temperature. Delta H increases more, so overall entropy increases. Use this formula for the calculation. Delta S is equal to delta H upon T. But always remember the unit. Unit of delta H must be in joule or calorie. It is generally given in kilojoule or kilocalorie, right? And temperature is kept in Kelvin. But at constant temperature, if the isothermal process is present, actually it is the constant pressure. at constant temperature delta S is equal to 2.303 nR log V2 by V1. Use this formula, or delta S. If isothermal is given, then use this formula for calculating the change in entropy. P1 by P2. So for numericals, use these formulas. Use these formulas. This is all about entropy. This is all about entropy. Now we see some question. Now we will do some question based on the entropy. Based on the entropy.